question number 18, a sphere of radius r has a power source of constant power P at its center. The temperature of the sphere is 500 Kelvin. It means that suppose there is a sphere of radius r and at center a power source is kept whose power is P. So in a steady state, the temperature of the surface of the sphere is 500 Kelvin. So in that situation, we can say that in a steady state, we can write P is equal to sigma into 4 pi r square into 500 raised to the power 4, as it is a black body as it is given in the question. Further, the sphere is now covered with a spherical shell of radius 4r. If the bodies are perfectly black bodies and there is no interaction with surrounding, then temperature of the outer surface of the shell is found to be 25 N Kelvin. Find the value of N. Now, this sphere is surrounded by another shell of radius 4r and power source is kept at the center. So in this situation, when the steady state has achieved, let the temperature of the outer surface of this shell is T. So in a steady state, we can say that P is equal to sigma into 4 pi into 4r square into T raised to the power 4. So if I can equate these two equations, then from T comes out to be 500 by 2. So this is equal to 250 Kelvin. So on comparison, the value of N comes out to be 10. So on comparison, the value of N comes out to be 10. So the correct answer for question number 18 is 10. Let's move to question number 19. In question number 19, a tall vertical cylinder of height h and cross-sectional area A is in uniform gravitational field. The cylinder is closed at both ends and densities at top and bottom of cylinder are rho naught by 4 and rho naught respectively. Density of gas at the middle of the column is rho naught by x. Find the value of 8x. Let's analyze the situation. Suppose this is a tall vertical cylinder and its cross-sectional area is A and its height is h. The density at the topmost position is rho naught by 4 and the density here is rho naught. Now I am considering a section at a distance y of length dy. So the difference in pressure dP can be written as minus, let the density here is rho, so rho g into dy, and we know that P is given by rho RT by M. So if I replace the value of P by rho RT by M, then we can write in this way, RT by M into d rho by rho is equal to minus g into dy. So if I integrate this equation, first from y is equal to 0, when the value of y is equal to 0, the value of rho becomes rho naught, and when the value of y becomes equal to h by 2, then the value of rho becomes rho naught by x. So this is my first equation, and in the second equation I have to integrate from y equal to 0 to y equal to h, and the limit of integration from here is rho naught to rho naught by 4. So from these two equations I get the value of x. So on solving, it comes out to be ln x is equal to ln 2. So x is equal to 2. So we have to find out the value of 8x. So the value of 8x is 16. So the correct answer for question number 19 is 16. Let's move to question number 20. In question number 20, radii of a tapered cylindrical wire of length L at its end are A and 2A. It is stretched by two forces, each of magnitude F, applied at its end. Young's modulus of material is Y. If extension produced in the wire is 6FL divided by phi and pi a square, then find the value of N. Suppose this is my tapered wire. The radius here it is given as A, and the radius here it is given as 2A. Now if I consider a segment at a distance x of length dx, so this length is dx. If I consider this section, cylindrical section, then I have to write the extension in this segment when F force is applied at both the ends. Let the extension in this segment of length dx is dy, then dy is equal to stress. So force is F divided by cross-sectional area. Let its radius is r. So pi r square, this is the stress, divided by Young's modulus into dx. And I find out the value of r at this position at a distance x. The value of r is a plus 2a minus a divided by L into x. And if I find out the total elongation in this wire of length L, then total elongation delta L is integration of dy as x varies from 0 to L. So if I do this integration, then it comes out to be FL divided by 2 times y into pi a square. So on making the comparison, the value of 6 by n comes out to be 1 by 2, or the value of n comes out to be 12. So the correct answer for question number 20 is 12. By this, I wish you all the best for your preparation. Have a good luck.